All right, welcome everybody. Welcome to another episode of web development. Let's take a look at where we have been, where we're going. So we're quickly approaching halfway point of our semester-long course, right? And we've been covering quite a bit of material related to how to build web applications, right? The first three modules that we covered, about 6 weeks worth of work, right? We talked about how to build the user interface using HTML, CSS, right? And we just covered how to use JavaScript, right, to be able to dynamically generate that user interface, right, to compute that user interface, based on some data structures and logic, right, and breaking out a large application into multiple constituent components and screens, right, and how to navigate between them, right, and how to pass attributes and data and parameters, right, encoded in the URL, right, so that screens can then uh, parameterize, right, their output, based on the data that is included in the URL. Right, we can encode the ID of a user or of a product or a course, right, or a module or assignment, right, and then we can use that information, encoded in the URL, to then run some logic to fetch the information that is correspondent to that ID, right, and then display the appropriate content. So we're gonna build on that on those skills, right? We're gonna go further today. Right? What we want to be able to do is not only be able to read the data and retrieve it and parameterize and compute it, but we also want to be able to modify the data, right? We would like to be able to change the state of the application as users interact with it, right? As users click on the screen or they type something on the keyboard, right? As they interact with the application, they modify the state of the application, right? And then the user interface needs to reflect those changes, right? That if we click on a delete button, right, we need to update the user interface to show that that particular item no longer exists, right? Or if we create new content and we post a question or a new course or a new post, right? We need to be able to show that, yeah, we've created this new data structure, has been added to some collection, some array, right? And then the user interface needs to be able to update, right, to give feedback to the user that indeed, yes, the state has changed, and the user interface reflects that change. Okay, so that's what we're going to be discussing for the next couple of weeks. Right, we're going to introduce how to maintain state in the application, either an individual component, right? How various components can share data amongst themselves, perhaps across multiple screens, right? And how to maintain, the overall state of the application, right? And how, different parts of the application can talk to one another and read and write to this data, right? And then reflect those changes in the user interface. Right, so that's the focus of the next couple of weeks. Also, we are introducing today the fourth assignment, right? That's going to give us a chance to practice some of these skills, right? We're going to, in the labs exercises, we're going to talk about, how to maintain state from primitive data types, simple integers and booleans, objects, right? Arrays, and very complex data structures, right? And then, within a component, and then how to share that across, the entire application. Also, there'll be a quiz this week, right? If being an online course, right, the quiz will be available for a couple of days, right? So again, find a slot of 20 minutes or so to take the quiz. And the midterm exam is quickly approaching, and that's going to be available all next week, right? And so the material for next week is whatever we cover today, right? So it'll be component state management, right? But not application state management. And I'll discuss that today, what we mean by that, right? We'll talk about there are two big buckets of how to maintain state in an application, right? And so we'll talk about what will be covered in the exam and what won't, right? So whatever we cover today will be on the exam, but not what we're going to cover next week, right? Next week we're going to talk about using application state level, right? And then how to use that, right, to enhance the Canvas application that we're working, right? So yeah, so that's coming up in the next lecture. And after that, we are going to have a spring break right at the beginning of next month, right? So yeah, that'll be great. All right. Any questions before we begin? Also, stick around at the after the lecture, right? I will have my office hours. Again, if you have any questions, you need a one-on-one help, you want to discuss the project, right? Just stick around and we'll have those discussions. Okay. All right, let's get started. All right, so let's talk about event handling, right? So up to this point, right, in the course, we have discussed, how to use React.js to compute the user interface, right? We can think of React as one big function, right, that transforms a data structure, right, and it computes like, how is it that that's going to render some user interface, right? And we provide the algorithm, right, of what functions I'm going to call what other functions, right? What loops are we going to be using, and then compute, that a such so array or such object, right, converts into this equivalent user interface, into this heading, into this list, right, into this table, right? We we provide the function that computes, that converts the data structure into, excuse me, React.js provides the function that computes. Oh my goodness, something going around. A lot of people getting sick. Um, I'm okay. Still, I'm okay. Yeah, so React.js provides the mechanism for being able to convert those data structures into an equivalent user interface. We haven't discussed how also users as they interact with the data structure, as they interact with the user interface, right, they generate a stream of events, right, as they type, on the keyboard or they move their mouse. And so we need to be able to process those events, right, and serialize them, and they will, they're meant to be manipulating some state information, right, some variable, some particular Boolean or integer, or maybe an array or a particular item in an array, right? Or some property in some object, right? So we're going to learn how is it that we handle those events as we click, drag, click, and type, right? And then how is it that those changes are reflected in the user interface, right? Right, so first of all, right, let's talk about handling the most simplest of events, right, which is just clicking, just moving your mouse, right, and just clicking on the screen or clicking on any element, right, and that can be done using the onClick attribute, right? The onClick attribute allows us to associate a function that will be invoked, once the click happens, right? And this could be applied to any element, right? More commonly, it is applied on a button, right? But it is not the only element. You could apply it to a heading, right? A div, a paragraph, anything can be made clickable, right? Just by applying the onClick. And then the onClick attribute, right? Then you provide a reference, right, to the function that you want to execute, right? That's going to handle the event, right? We call those functions event handlers, right? So these functions that handle the event, we call them event handlers, right? And the function can be either implemented outside as a regular function using either the new syntax, right, the new arrow syntax, or you could use the older function syntax, right? Either way works. And so once you declare them, once you declare those functions could be implemented in the same file, or they could be implemented in a separate file and then imported, right? As long as you have that reference, that function will be invoked and it'll run, right? And will provide, we'll do some work. We'll do some work, right? You could also embed the function right inside of the on-click expression, right? As an expression, as opposed to declaring and implemented it outside in a separate function, you can implement it right inside of the expression curly brackets like this, right? So, and using the newer syntax, right? If we use the new syntax in the arrow function, right? If there's only one line, one statement, then we can use the newer syntax where we can drop the curly brackets, right? The body of the function, right? Now, if the body of the function is a little more complex, right? We can certainly do that too, right? We can open up a curly bracket, right, and add several statements, right? Of which one statement could be invoking one function, another statement could be another invoking some other function. You could be doing some work right here, right, in the expression. Now, if it's more than just a few lines of code, right, this is not considered best practice, right? You should minimize the amount of work that you do inline right there inside of the on-click expression, right? And so it's better to if it's a complex algorithm, it's better to have your own function and then invoke that function. Okay, pretty good. Yes. Another thing that I want to point out is that notice that this is we're calling a function here, right? Life is good. And notice that we're passing a parameter to that function. See, life is and then good. Okay. And so now one might say, well, over here, you just had a reference to the function just like that, hello. Whereas over here, because we have this parameter, right, we wrapped it inside of another function. See that? This is a function declaration, right? And then inside, we're calling another function. One might ask, well, why bother putting it, this extra syntax of parentheses and arrow and whatnot, right? We could have just dropped that perhaps, right, and just call life is good. Not so, right? Yeah, don't do that. Whenever you have the parentheses here, right, when you have a function name and then a parentheses, that function will be invoked immediately. Okay, so if it tries to evaluate this function, it should try evaluate the function, and it doesn't have this outer parentheses and the arrow, okay, then it will immediately execute life is good, right? Even if you did not click it, right? Because it interprets the parentheses, on the right-hand side of a function, it interprets it as an invocation, right? And what that's going to do is that, it's going to cause the page or the component to re-render, and the re-rendering will cause this function to be called again, which will cause a re-render. So it'll end up in an infinite loop. Okay, so make sure that if you have a parenthesis here, right, that you're going to invoke something, right, do not just declare directly in the expression. Make sure to wrap it inside of an outer function, right? We call this outer function, we call it a closure, right? So a closure, right, it's a JavaScript feature, right, that allows you to postpone the execution of the body, right? It won't be invoked immediately, right? Whatever the body of the function is, it will be invoked later. What closures do also is that they take a snapshot of the state of the application of the outer context, right? And it remembers, what was the context? What was the values of all the variables, right, within my context, so that when I invoke the function, right, it can recall all those all those values. It doesn't really matter here, right? Well, it does that. It does remember that there was a declaration of live is and hello, right? So it remembers those declarations, so it can invoke them. But closures are more than that. But at a minimum, right, what they do is they allow you to postpone the invocation of the body and say, well, don't run this right away. Only run it when when you actually do the click. Okay. All right. So yeah, don't forget. If you don't have any arguments and the function doesn't have any arguments like hello, then yeah, you can certainly just use the name of the function without the parentheses. Careful, no parentheses, right? Because if you put the parentheses, it's going to be invoked. You'll get in the infinite loop. So yeah, so if you don't have parentheses, yeah, you can just put the reference of the function and you're good. But if you need to pass an argument, right, make sure to remember to put it inside of a closure. Okay. Right. Yeah. So on click, when we click on it, right, invokes the hello function. Right. When we click on the life is good, it invokes this life is good passing the string. Right. And then we call this inline implementation where we have a more complex set of statements inside of the event handler inline, implemented inline with the onClick attribute. Okay. Yeah, this is a reminder, right, that if you are going to invoke a function that where you need to pass arguments to it, to make sure to embed it, inside of a closure, right? Don't do this, right? Of not putting the closure around it, right? Because that will cause an infinite loop. Another thing that you can do in JavaScript is to pass functions. You can pass references to functions, right? In the parameter list, right? You can pass primitive data types. Obviously, you can pass integers. You can pass strings, booleans as part of the parameters of a function. But more interesting, you can pass a function itself, a reference to a function. So for instance, here's an example, right, of a component, right, that is accepting, right, in the attribute list, right, as a parameter, a reference to a function. And here we're just declaring, right, because it's TypeScript, any parameter that we're passing to a function needs to be, we need to define the type of that function. So we're just here saying that, hey, somebody's passing us a reference to a function. We're saying, oh, it's of type, we're saying that that parameter there is of type function, which doesn't return anything, right? Returns void. Right? So this is just a declaration of the parameter that we're being passed. And then now that I have a reference to that function, internally, I can invoke that function. I can treat it like any other function, right? Either a function that I created, like this guy. We're creating the function here, and I can use a reference to it. Or somebody can pass me a reference to that function, and I can use it inside of an on-click. A button will invoke that function. Right? Oftentimes, this is referred to as a callback. We are passing a callback function so an inner component, right, can call us back. Right? We are the parent, right? We're delegating some work to some child component. So we are the maybe an entire screen, right? In the screen, you might have multiple components. You might have the header component. You might have the footer component. A couple of sidebars. Each one in its own implemented in its own file. So me as a screen, right? I can play the role of orchestrating the communication between all these components, right? That maybe a sidebar here, you're clicking and adding things to, adding or removing things, but then you need to notify maybe some other component. So me as a screen, I can orchestrate multiple components. I can maintain the state, right? But I can pass functions, right, to all my smaller components so that they can notify me, right, of things that are happening, within each one of the components. So you would pass a reference to a function like this, and then each component can then notify me that something happened, that somebody clicked on delete, on a post. So we need to go and do that work of removing the post. So here's the example of the parent component, right? Lat4 component, say, that has a reference to the child component, and then it has a function that it can pass down to the child component, right? That it can use to notify me, right? A common use of this is perhaps, we'll see a little later, where you might have an array of to-dos. So you might have a component that is the owner of the data structure, an array of all the to-do objects, right? And then iterates over them, and each item is rendered by a separate component, right? And then the separate component can have, can be fairly complex, rendering each line item, each, to-do item. And you might have input fields in there, you might have delete buttons, you might have, drop downs, blah, 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 right? And so, but the work of deleting, doesn't belong to any one item. It belongs to the parent. The parent is maintaining the data structure. So each one of the components, if you click on the delete button on each one of the items, they need to notify the parent. Says, hey, somebody clicked on the delete button. You need to update that array. Remove me, right, and then re-render the items, right? So with the ones you just removed, missing. Yes. So we'll see an example of that a little later, but that's the intent, right? That you can pass functions so that they can call me back.
Hi, Professor. I have a question. So previously for the function, then it's taking a parameter of type that's a function whose function body is void. So I'm just wondering, like, how can it take a function whose body is not void?
This is this is not the body is void. This is saying that the return type is void.
Oh, I
This,
get it. Thank you.
yeah, I'm saying that the function is not returning anything. If it were returning something, we would put here, if it's returning a string, then we would say returns a string, or an object or Boolean or whatever.
Okay, and then we are only having it because we are using TypeScript, which requires like type.
Right, we need to declare what this is, right? If I was passing a string or an integer, then this would say something something string, something something integer or number.
Okay, thank you.
But because you're passing me a function, I need to say, oh, this is a function, and if that function takes arguments, then I need to declare the arguments. And if that function returns something, then I need to say what it returns.
Okay, got you.
Yep. All right, let's talk about component state. And here I want to make the distinction at that we can maintain state at different levels, right? We can maintain it at a very granular level where each component manages its own state, right? And the distinction is that, yeah, we have that each component can maintain its own state, but then, if oftentimes we need a state that is higher or can go across multiple components, right? And so those are two types of level of state, right? That the component state is very granular, right? Self um, it's very modular, right? And it doesn't spread across the entire application, right? So uh, and so we're going to learn how to deal with both of them, right? How do you deal with the component state at the granular level, and then we'll talk about, how do you work with state at the entire application level, right? So component state, right, is it's something very common that oftentimes we take for granted, right? That when we use any UI widget, right? Perhaps even a simple button, right? A simple button needs to know whether it's being clicked or not, right? Whether it's active or not active, right? So it has different states that it can be at, right? That it has been clicked, not clicked, right? It's active, not active, read only, right? Disabled, right? So depending on the state, the button needs to behave one way or another. Okay. So internally, it's already maintaining its own state, right? And it behaves accordingly depending on that state. Same thing for drop down, right? If you have a little drop down, it needs to be able to maintain, how many options does it have, right? Which is the current option that is selected, right? Whether you can select multiple options, right? And things like that. So internally, all these widgets are maintaining internally, several variables, booleans, arrays, right? They internally they have these variables that allow it to keep track of the information that is rendering. Okay, so we need to do the same thing. At each level, whenever we create a new component usually is a combination of multiple components, right? Lower level components, and we combine it to make higher level components, right? But then the same thing happens, right? Our component needs to be able to maintain state. Okay. Uh, so, and what do we mean by state, right? And by state, we mean the collection of values that are being maintained at particular variables, right? If you collect all the variables of an application, right, all the Boolean variables and the strings and integers and arrays and objects, right? If you collect all those variables, right, that might be across multiple components, right, spread out all over the place, right? If you take a snapshot of what are all those variables and what are all those values, okay, we would call that, that is the current state of the application, right? And typically there's an equivalent rendering of the screen that correlates to that particular state, right? At all times, presumably, right, these variables control what is it that you see on the screen, right? And as the state changes over time, right, then the user interface should reflect those changes. Okay? Uh, so here's a really trivial example of a counter where we have a really simple state, the count, right? And that count, we're initializing the state of this component, that to set it, initially to say 7, right? And we print out the count, okay? And then, well, we already know how to do that, right? We have a little variable, and then we can just display the value, the current value, like that, right? So this is nothing new, right? We have a variable that, we've even done something more complex where we have an array of courses and modules and assignments, right? I mean, we have fairly complex data structures, right? We can iterate over them, blah, 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 and then we can compute what the rendering is. So that's nothing new. We know how to render the current state, right, on the screen. What we don't know is, well, what happens if the value of that variable changes over time, right? Notice that I've made sure to declare this with let as opposed to const. Okay. And so in this case, right, presumably count can change over time, right? So what happens? How would it change? Well, we know how to handle an event, right? Again, the simplest of events is click. So we could, declare an onClick event handler that updates, see that? Updates the value of count. Okay, so that if I click on the up button, right, I increment the value of count, and then I can just log it to the console, right? And same thing for decrementing. If I click on down, right, I would decrement the value of count, right, and then the console, I would display the value of console. Right? And if I run this, right, and and I click on the different buttons, I would see, that in the console, it would reflect that indeed the count was incrementing and decrementing, right? So if I click on plus, right, just go 7, 8, 9, blah, blah, blah. If I click on minus, right, it goes down. And so it's behaving as expected, except that the rendering here in the counter of count actually doesn't change, right? It just stays at 7, right? It just stays at 7, even though in the console I can see that there is evidence that the value is indeed changing over time. 7, 8, 9, 10, 9, 8, 7, 8, 9, So, so it's up and down. So it is changing, right? But the user interface is not re-rendering. Interesting. Okay. And so that's what we need to fix, right? Why is it not rendering? Well, there are several reasons. Well, one of the main reasons is that React.js is just lazy. Okay, it's lazy. Um, and what I mean by that, it tries to optimize, right? Optimize the rendering on the screen, right? Rendering something on the screen is very expensive, right? It's very compute intensive. So if it doesn't need to, right, it'll try to avoid, rendering something on the screen. Okay, and so as far as the rendering engine is concerned, it's done rendering the screen, right? There's nothing has happened to notify it that we should render again the screen because something has changed, right? As far as it's concerned, it has gone through the loop that renders the screen, and there's no reason why go through that loop again, right? So we need a mechanism to be able to tell the React and rendering engine, say, hey, something changed, the state of the application has changed, please re-render the screen, right? Right. So how do we do that? Okay, so to do that, we are not going to use declarations of variables like this, right? If we need a constant or we need something that doesn't change, certainly this is okay. But if we need things to not only declare variables, but also be able to modify these variables and also let the rendering engine say, hey, this change is worth your while, right, to re-render the screen, right? So the way we do that is by instead using the use state hook, right? So the use state hook, right, is part of the core React library, right? And it's used for declaring variables, right, that we know that are going to change over time, right? And we need a mechanism to let the rendering engine know that, hey, something happened, the value of this state has changed, of this variable has changed, and you should go ahead and re-render the screen, right? Wherever this variable is being used, right? Go in and do some surgery, right? And make sure that is up to date, that it reflects the changes to this variable. And these variables, we're going to refer to them as state variables, right? So here, what the way that works is that we declare the variable count, right? And we declare a modifier, a function that modifies the state variable. Okay. And notice that it says const. It's a constant. And you might say, wait a minute, aren't we going to modify the value of count? Yes, we are going to modify the value of count, but not the way we do it here by directly manipulating the state variable, right? It is a constant. We can't do that, right? We can't do count plus plus because it is a constant. Instead, right? Instead, we're going to always use the mutator function that is going to do two things. It's going to indeed modify the value of the variable, right? And also tell React, hey, React, things have changed. Please go ahead and re-render the screen at your earliest convenience, okay? At your earliest convenience, go ahead. Next time you have some time, please go ahead and re-render the screen. Okay, and what happens is that use state, there's a loop goes and the component re-renders, right? And then use state returns, right, the new value of count. So for instance, if I click on set count on the up button, right, it says that the new value should be count plus 1. Okay, so that means that the state has changed from 7 to 8, say, right? And that causes a re-rendering of the component. It's gonna it's going to pass through this again, right? And so it's going, new state is now going to return a new version of count, which will be 8, right? If we click on up, right? So 8, 9, 10, it re-renders the whole thing. Now it doesn't render everything. It only renders the portions of the user interface that are affected by the change of this variable. For instance, the only place where we are actually rendering count is the header, right? So only the header really is modified. Everything else, the buttons, right, don't need to be modified, right? So those are not, the DOM is not going in and re-rendering the button itself. It's only going in and doing some surgery, right, and modifying the string that depend on those changes. Make sense? Okay. Yeah, so we call these mutator function, we also call them setter functions, right? So these are state variables. So count is now referred to as a state variable, right? And then set count is the mutator or setter function that modifies or mutates the value of the state variable. Make sense? Also, we can initialize the value of the state variable by passing a parameter, right, to the use state, right, which initializes the value of the state variable, right? What else? Also, notice the square brackets, right? Notice the square brackets. So that means that use state is returning an array. It's returning an array, and what we're doing here on the left side is that we are destructing that array, right? So use state returns an array that has 2 items in the array. The first item, right, is the value is the current value of the state variable, right? And what we're doing here is that we are declaring a new constant that gets a reference or gets the value of the state variable. The second item in that array is a function. Okay. And what we're doing here is that we are destructing and we are associating, we are assigning that function that is being returned as the second item in the array in the return value, and we're assigning it to a local constant, and we're giving it the name set count. Right? Now these names, because this is a destructor, it's an array destructor, these names could be whatever we choose. Okay. Now, because we are working with count, right, the naming convention is that you name this as a noun that makes sense to you, right, that describes what it is, the state variable, the intent of the state variable, and also the setter, also as a naming convention, right, we use the keyword set followed by a capitalized version of the state variable, okay? But those are just conventions, right? Nobody's is enforcing that, right? We could call this X and Y, and this would still work, right? Obviously, this would be X, X plus 1, X minus 1, and set count, if we call it Y, then this would be, Y X plus 1 and Y X minus 1, right? And that's a hint on something that might happen or not, right, in an upcoming quiz or exam, right? As you might have noticed on many of my quizzes, I tend to use, either single character names for my variables, right, and or functions, right? So you can expect that, to continue. Okay. So yeah, so these names can be arbitrary. You can make them whatever you want as long as they are declared in that order. The first one holds the value of the state variable. The other one is a reference to the function that mutates that variable. Okay. So that was an
Hi,
example
Professor.
of, yes.
I have a question. Sorry to interrupt you.
Oh,
So,
sure.
even if we are declaring the count as a constant, then how is the set function able to mutate it?
Yeah. So what happens is that, once you mutator, the whole component re-renders. So it goes through this loop again, right? It goes through this line again, and use state is invoked again, right? Which is maintaining the state, right? And it returns again a new array, a brand new array, which again we associate to these local constants, right? So we're never actually changing this here, right? So for instance, if you try to do count plus plus, right? If you try to do what we did here, count plus plus, the compiler won't let you, right? It'll say, no, you can't modify because you declared it as a constant, right? So what's happening here is that useState is computing a new value for count and is returning a new array whose first item is the new value of count, which is being assigned to a local constant.
Okay, I see. Thank you.
Sure. So yeah, so this is an example of using state variables in the case of an integer, right? This is just an integer. Let's take a look at other examples where we use other data types, right? And we'll get increasingly more interesting, increasingly more complex, right? So for instance, let's talk about Boolean variables, right? So for instance, here we are declaring a done and set done, right? So like a flag, whether you have a to-do that you're done or you're not done, or some task, right? And you want to be able to click it and say, yeah, I'm done. And perhaps in the form of a radio button or maybe a checkbox or whatever, right? So we're initializing done as a Boolean state variable, and we're initializing it to be true. Right? And then we can use it to say, right, hide or show, right, a particular item, like a div here, right? So div here is an alert box, right? And it's either shows or doesn't show if, depending on whether done is true or false. If done is true, then the div displays. If done is false, then it doesn't display. Now, initially done is true, right? So done is true. So the alert box is displayed. It says, "Yay, you are done." Right? Now, how could it change? Well, it could change by using a checkbox or radio button, right? Or really anything that could modify the value that could we could invoke the set done, right? Now we could use the input field of type checkbox. We could say, and then most input fields that can change value over time have an on-change event handler. So everybody has an on-click because everything can be clicked, right? A header could be clicked, a div, a paragraph, anything can be clicked. So everybody has an on-click that you could override, right? You can configure, but only elements that can change their state, their internal state, have an on change, right? So for instance, a checkbox, radio buttons, an input field that you can type text, right? A text area, right? A drop down, right? So they all have internal state that can change over time, right? And they can notify us of something happened, right? So an input of type checkbox can internally know whether it's checked or not, right? And so that it knows how to render, whether it renders or not, right? And we can set the state. We can set the state of the checkbox by using an attribute called checked. So checked allows us to set, right, the state of the checkbox. You can say checked, and so if it's checked true, then you see that it's initially selected. If done is false, then it shows it unchecked, right? So checked allows us to modify the internal state of the checkbox. We can also read the state, right? If something happened to it. For instance, it already has an on-click event handler. It already has, right, knows how to handle the click on the check. So all checkboxes, all radio buttons, right, already internally can handle on a click events, right? And they know that, right, that if it's checked and you click it, then it knows that internally its state should change to unchecked, right? Internally. The problem is that if we have checked equal done, it will always override. So this checked equal done, if done doesn't change, if done doesn't change, right, then this checkbox will always be checked regardless of whether you click it, regardless of whether you click it, right? Because it's always having its state overwritten by the value of done, right? And since it's always true, it will always be checked, even if you try to uncheck it, right? Unless we use an onchange, right? So what the onchange does is that it notifies us, hey, somebody checked me, and my intent is to swap states, right? If I was checked, I want to become unchecked. So it's notifying me. It says, hey, my internal state changed. And then what I can do says, oh, okay, I am maintaining your state. I am maintaining your state, because I am writing to you. I'm overriding you. So what I'm going to do is that I am going to listen to you, and I'm going to flip the done, right, to be its negation. So if it was true, it will become false. If it's false, it will become true. Right? So since this has become true, set done to not true, it becomes false. So checked now becomes false, and it's on checks. Make sense? So this is a behavior that the checkbox already supported. It already did it on its own. Here, what we're doing is that we're integrating with its state, right, and its event handling internally, so that we can, from the outside, right, we can integrate and maintain that state, right, so that perhaps we can notify other components, right? We can hide and show other components. We can do all sorts of other logic here. Make sense? Right? Obviously checkboxes without check and without on change already behaves with checking and unchecking, right, on its own. Here we are taking over its behavior so that we can integrate with it, right, and then make things happen at the rest of the user interface, right? We can hide, show things around and whatnot, and maybe modify other data structures and whatever. Make sense? Okay, so let's look at another example of a slightly more complex data type, right? So we've looked at integers, right, and Boolean, and each one is increasingly more interesting and more nuanced and has some, more things to deal with, right? Let's look at the string, how to manipulate, how to deal with strings, right? So here we're declaring a state variable called first name, and then a mutator called set first name, right? That is going to allow us to modify a string, right? So we're initializing it with a string here, right? And so first name gets the value John, and set first name will allow us to modify it. Okay. Okay, so here we're using an input field of type texts. Notice that we didn't explicitly declare this to be of type text, but it's actually the default type of an input field. Input fields, if you don't say the type, by default, they are text, right? Meaning you can type any character in there, right? Numbers, ASCII, whatnot, right? Uh, so here what we're doing is that we're initializing the value of default value, right? And what this does is that default value, there's value and there's default value, right? So value, like we did here, oh, we don't have, yeah, yeah, we don't have an example of value. Yeah, we don't, not yet. So there's two attributes that you can use. There's value and there's default value. The value, right, which I don't have here, right, will initialize the value, and it won't. The value will always be whatever the attribute, whatever the value that is being assigned to, right? Whereas default value, it uses the variable to set its initial value, but then you can change it. You can start typing, right, and it changes over time, right? Whereas if it were value, right, and it sets the value of first name, and if you try to type, it won't even let you type, right? It's the value is always stuck at John Doe or whatnot, right? You can't even type it. Whereas default value, right, it will set it but then allow you to change it as you go. Yeah. Now, in either case, right, the first name would always be just John, right? Even if you type away whatever, right? Nobody's changing the value of first name. Only if you use an onChange. An onChange reflects, right, the internal values, the internal behavior of the input field, and allows us to be notified that, hey, somebody's actually typing in the input field, right? And internally, I have all these characters. You want me to tell you what those characters are? Right? And so we can be notified here that, oh, wait, somebody's typing at the text here, right? And so we want to be able to integrate with that internal state and be notified, hey, did your internal state change? And so we can use the onChange. And onChange will notify us that, hey, there are new characters. Somebody's typing here, right? And so it can invoke us. We can provide an event handler, again, either inline like we're doing here, or it could be a separate function, right? Declared outside. And it can notify us with an event that describes what happened. What is what just happened? Okay. And so, for instance, these event objects have a lot of meta information, including what time was it when the event occurred, right? What who was the element, the DOM element that generated the event. But one of the more interesting things that it has is that it has first it has event.target. It's a reference to the DOM element that generated the event. In our case, it's our text input field. And then also has a dot value inside of the target, right? It's an attribute that tells us what is the current value, right, of that DOM element, right? If it has a value. Not all elements have values, but certainly text areas do. Text input fields, select statements, things like that, right? So it tells us, hey, what is the current set of strings that it has captured so far? And what we're going to do is that we can use that to update our first name, right, and make sure that we are in sync, that your internal state management of all the characters you've captured, I am capturing it too, so that I can keep track of it in an outside event, in an outside state variable, right? Because I want to display somewhere else. I want to notify someone in the in the database or something. Maybe I want to save it, right? So I can read into the internal state variables. Okay. How about dates? Dates is also again an increasingly complex data type. Right? So strings is a collection of characters, right? A date is a collection of time units, right? That represents more granular parts of the date, right? Of time units, right? Where you can keep track of milliseconds, of seconds, minutes, hours, days, months, years, right? And so it's a data structure that has predefined properties, right? That we can read individually, we can set individually that represent a particular time, right? In history. And so you can create a new instance of the date, right? Like this new date. And what this does is that it goes out to the operating system and asks us, hey, what time is it? Or what date is it? And it creates an object that represents the current time on your browser. The browsers, wherever the operating system is running locally to your particular geographical area. Right? So here we're initializing start date, the new instance of date of current date, and then here I have a little utility function that can take as arguments the date object, right? And then just breaks it out uh, into different constituent pieces of month, date, and year, right? And just formats it in a way that is readable for humans. Actually, this formats it in a particular string format that is useful for date pickers, right? In a browser, you can have a date picker using a input of type date. So an input of type date, right, allows you to not only set the date, right, but also read the date, right? So again, all of these components have both, we can set the value, but we can also read its internal state, right? So here again, we have an example of an input field of type date where we can initialize its value, right, with a formatted string date, right? The standard format for dates for date picker is year, month, and day, right? In the format of 4 characters for the year, 2 characters for the month, and 2 characters for the day, right? So that's what we're doing here, right? This little function just formats it so that it's 4 characters for the year dash 2 characters for the month dash 2 characters for the day, right? And depending on whether the date is, or the month, or the date is, or the day is below 10, right? So we need it. We need to pad it with zeros, right? So the month and the day need to be 01, 02, 03, 09, 10, 11, and 12. Okay. So yeah, so we need to pad it, make sure that we add zeros in front of the date. So this is what it does. It puts in the right format. Something that this might not take into account is that a month, right? They're all zero based. So January is not 1 but 0. So this might actually not. Oh yeah, it actually does +1 +1. So yeah, so it does take into account the fact that these values are zero based. So careful there. So yeah, so it formats it so that we can set the value, but we can also read the internal state of the date picker, right? So that if you change and select a different date, right, we can read the current date, right, and then we can modify the start date, right, to be a new instance of that date, right? So this is important, right, because this date is being maintained in 2 places, right, in two different formats, right? The browser date picker wants it in year dash month dash day, right, in a string format, whereas the state variable wants it in as an instance of date, right? So we find ourselves back and forth converting between the two data types, right? So you just have to be careful, right, that we always maintain the correct instance, right, and then we convert it into whatever uh, representational format you want it for display. Okay. Yeah, so this is an example of a date picker. You click it, right, and it takes the day, the month, and year, right, and then just displays it. Okay. All right, so let's go a little further, right? Here's an example of dealing with with something a little more involved, right? The an object state variable, right? So we already saw an example of that in the date, right? The date is already an object instance that has predefined properties of month, day, year, minutes, seconds, milliseconds, blah, 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 right? But we can also create our own object, right? With our own properties, with our own values. Right? So here we have an example of creating an object of our own, right? With properties name and age, presumably representing some person, whatever, right? And so we're declaring our state variables person, and set person allows us to modify the properties, the individual properties of the object. Okay. Also, an example of rendering, right? Of rendering the object on the screen, mostly for debugging purposes, right? This is very convenient for us developers, where we can actually see a graphical representation of the object itself with nicely formatted with curly brackets and indentation and whatnot, right? So this is very useful for debugging purposes. It might even be worth creating a little component, right? Reusable component where you can just pass it a reference to a JSON object, right? And then it'll just display it nicely formatted. Right? So yeah, so we here is so that we can keep track of seeing what happens to this person when we modify it and confirm that the properties are changing, whether it's the name of the object, right, or the age or the name and whatnot, right? So how do we change each individual object property? Well, we already saw how to modify strings, and we already saw how to modify integers. Okay, uh, but here's an example of two primitive data types combined into a more complex data type, right, of an object. And so here we have two input fields, each one dealing with individual portions of the object. One is dealing with the string, person name, and the other one is dealing with the person age. Right. So one of them displays the name of the person, the other one the age of the person. Right. So here we are copying the state variable person into the state of each individual input field, right? Which because they're they are input fields, each one will represent it in its own representation, typically as a string, right? Um, and so the input field by default is of type text, right? So this is fine, right? Name is text, so it is appropriately set, right, as its equivalent data type. And same thing with the age, right? It's an integer. In this case, it's being converted into a string representation because it's type text. Perhaps a better version implementation of this would be that the type would be number as opposed to the default text. So I guess that might be a better implementation. We should always strive to use the most strongly typed input field, right, to make sure that it's formatting that is equivalent to whatever data type is being assigned to it, right? So we are writing to the internal state of each input field, but you can also read from it, as folks start typing and changing the name of the person, or typing and say and the age of the person. You can edit it, right? So as they edit, we want to modify the state of our object. And what we're going to do is that what we'll do is that we are going to modify the object by first, calculating a brand new object instance of which we're first going to copy over the old state, right, which is dot 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 person. So we are spreading and copying all the properties from the old person with the old age, with the old name, comma, see that? And then we have name. So we're going to override. So we just copied all the old values, the old name, the old age, but we're going to override, the name with a new value for the name, right? Which was going to include the, whatever you typed, right? We're going to grab the value internal state of the input field that has the current collection of all the strings, and we're going to update the object so that we're copying all the small constituent pieces, edited with different input fields into one collective object, right? So same thing for the age, right? We are copying the old person, right, with the old age, with the old name, and then we're going to override the age, right, by taking the value of the input field, whatever they type, whatever new age they type. We're going to make sure that is an integer. We're going to parse it as an integer so that we can then copy it and keep track of it, in our own state variable. And so our state variable is basically the collection of the properties that are being, manipulated in each individual input field, drop down or check boxes and whatnot. So in here we could have, a fairly complex object, and you might want to practice this, right, where we have, a couple of strings for the first name and last name, maybe a date object where we have the date of birth, right? And then we have, a couple Booleans, whether you're married, whether you're a tenured professor, right? And then, for the a numeric value maybe for your salary or whatnot. Okay, so that'd be a great uh, you know practice for you, right? To practice this skill set, right? Okay, let's look at like an even more interesting data structure, an array, right? An array is a linear collection of values, right? That have a very well defined first, second, third, right? In a particular order, right? Collects all these items. And we're already seeing examples of iterating over arrays, right? Where we can display each line item. But in this case, we should be able to modify the state, right? So here we have an array, right? State variable that is holding the initial value of the array, numbers 1 through 5. And here we're doing something simple. These are just integers, but these could be other data types. These could be strings. These could be objects, entire objects. But let's keep it simple and just an array of integers. And now, as we start working with more and more complex data types, our mutators is worth, as each mutator, you have more types of operations, right, that you can do on more complex data types, right, with integers and strings and whatnot. There's nothing more to do than just change its current value, and that's it. But as you start working with more complex data types, like an array or even an object that contains arrays, and those arrays contain objects, well, now the operations start becoming more and more complex, right? So instead of just having a set array, oftentimes, the different operations is worth, implementing dedicated functions, right, that do different operations. In this case, in an array, you could perhaps add to an array. You can delete a particular item. Maybe you can modify an individual item. You can swap items. You can sort them. You can find things. So an array, gives you a much more rich set of operations that you can do in an array, right? You can grow the array. You can put it at the top of the array, at the end of the array. There's all sorts of operations that you can do in an array. Here are two trivial ones, right? Just to give you an idea of what you can do with an array. And so one is you can add an array. You can add an element to an array, or you can delete a particular element at a particular index, right? So let's look at how they're implemented, right? So for instance, if you want to add an element in the array, well, again, adding an element in the array, is it at the beginning? Is it at the end? In the middle? You want to insert something? We can keep it simple and we'll say, well, adding an element just, appends an item at the end of the array, right? But, if you feel curious enough, go ahead and implement other more interesting operations, such as, add an element at a particular index, right? Or at the beginning or at the end. Here is just as simple as adding a random number at the end of the array. And how we're doing that, we're saying, notice we're using the mutator. So somebody's going to call this add element, probably this button here. You're going to call add element, and it's going to set the array to be a new array, a brand new array, right? There it is. So set the array, a brand new array, whose first set of items is going to be a copy of the old array, right? So we're going to spread the old array onto this new array, copying all the items. So it'll have 1 through 5 in there, comma, a brand new value, which is some random value between 0 and 100. Okay, so it will be displayed or added at the end of the array, and that will be the new array. This causes the state to change. The whole component re-renders. The use state comes back with a new array, which will be 1, 2, 3, 4, 5, comma 32, or whatever new random. Make sense? The delete element can take as argument, for instance, an index, right, of which item are we removing, and presumably that will be handled by, each delete button in each item will know which index you're in, and it'll pass in what that index that we will cause a new array to be computed. How? We're going to set the array to a brand new array, right, which will be the result of filtering out that particular item out of the array. Right? So it's going to it's going to go through the array.filter. If you remember, array.filter computes a new array that is smaller, throwing out some elements out of the array. Here, which items are we removing? Well, we're removing the item whose index is equal to the index that we want to remove, or we're only keeping those items that whose index is not the index we want to remove. So this is filtering out that particular item. Okay. Now as you're rendering, here you have a UL, right, that iterates over the array, right, and each item is the value 1, 2, 3, 4, 5, right, and it's being rendered inside of a line item, and the line item is rendering the item right here. See that? And that with the 1, the 2, the 3, 4, and so on. And also notice here the map. The map has two arguments, right? Up to this point, the map function that we've looked at so far only had one parameter, the actual item, as you're iterating over the array. Well, there's an additional optional parameter that we have been ignoring up to this point, but it's there in it nevertheless, right? And so that index tells you, as you're iterating over the array, where are you in the array? What position are you in the array? 0, 1, 2, 3, which position? So that's what index does. Another thing here is that here we have a property called key that we haven't seen before, right? And so that key property is it's a property that is required by React, that whenever we are generating dynamic items, right, in a loop or something like that, we have to provide some value that is unique, right, to help the rendering engine. The rendering engine needs to be able to maintain, in its memory, say, okay, well, I'm rendering all these items in the DOM. I want to make sure that, hey, my, whatever's drawn on the DOM, right, I have an in-memory representation of that data structure that I used, right, to generate that DOM, right? And so to keep a mapping between, what's in memory and what's rendered on DOM, right, it needs to maintain that that accounting, right, of which item matches what, right? So that's what this is used, right? The key, you have to guarantee it to have a unique value within that scope, right? So index is something that is guaranteed to be unique. 0, 1, 2, 3, they're unique, right? So that's a good choice. But also that index can be used, right? Can be used for whenever you click on the delete element. See that? Notice that next to the item, we're going to implement a button that if you click it, it'll invoke the delete item or delete element, and it'll pass as argument the index. Notice that we've used the closure here, the closure syntax. So we've wrapped our invocation here, inside of a closure, right? Making sure that these delete elements are not being invoked immediately; they're being postponed, right? Only when you click on the button delete, then it'll invoke delete element and it'll call index. And here's where it's important, the feature of the closure. The closure needs to remember all these index values, right? As it's iterating, the index value changes, right? The first time around is 0, the second time around is 1 and whatnot, right? So each button needs to remember what the value of index was when it was created. And that's where the closure comes in as an important feature. At the time of this button, when it was created the first time around, index was 0. So the closure captures that. It says, okay, I'll remember that when I was declared, as a function, the values around me, the state around me was that index was 0. Then when it goes to the next button, the next iteration, index now is 1. It creates a new button, and the closure will remember what index was in this time around. It will be 1, and then 2, and then 3, and 4. So each button has its own remembering of what index was when the whole thing was declared. That's the importance of the closure feature, right? So that when you click it, right, it'll pass the correct index, and then it'll come in here. It will know which one to filter out, right? The state will change, and it'll re-render with a smaller array because you removed an item, right? And it'll just disappear, right? And also with the add element up here, right? Notice that add element, when we click it, calls add element. Notice that it's not in a closure. See that? We could have added it in a closure. We could have said, parentheses, arrow, add element, parentheses. It would have worked the same way. But there's no need to, because there's no need. We're not passing any arguments to it, no parameters. So here we decided to use the more compact syntax. I don't need to pass an array. I could just pass you a reference to the add element, which will be invoked when I click on the add element button. And what it'll do, it'll come in here, right, and it will calculate a new math floor random value at the end of the array. It'll cause the component to re-render, a new array with a new item at the end, right? And it'll iterate and render the items. Make sense? In this case, the closure is not needed. There's no need for it to remember anything, right? So this syntax works perfectly well. Okay. All right. So oftentimes we need to be able to share the state between components, right? Up to this point, right? Each component has been maintaining its own state. Okay. The array component here has its own little state, which is an array of items, right? Over here the object was an object that was declared inside of this one component. No one else knew about this component, this object. But sometimes we need to share, right? That we have one component maintaining the state, where it declares the state, it has a setter for that state, right? But that component might not be responsible for displaying the state, right? Well, here we do, right? We have the counter, we're displaying the counter, right? But we could also share that state with other components. One easy way to share the state with another component is to pass it as a parameter, right? We can pass it as attributes and then references to our local state variable, right? So here we have some other component, which is a child of ours, right? So this is a parent component that is the one who's maintaining the state. So the parent component is the one who's responsible for the state, right? Maintaining the state and mutating the state. But then we can share the burden with a child component and say, well, I'm going to pass you a reference, right, to the state variable and the setter, so that you can receive that, you can receive those references of the value and the function and the callback, and then in your implementation you can have your own buttons, right? And then even though you're not responsible for maintaining the state, right, you don't have the state, you have a copy of it, you can notify your parent. You can notify your parent, if you click, increment, decrement, blah, 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 you can notify your parent, hey, parent, right? My user clicked on these buttons. I don't know what to do with them. So it'll tell the parent, hey, parent, you are maintaining the state. I'm only notifying you of what happened, right? But I'm not maintaining the state. I'll notify you. You are the one who is actually going to set the counter to whatever +1 or -1. You change the state. You cause a re-rendering of the component of the parent component. A new value of the counter gets computed, and then it gets shared again with the child, with child components, right? We pass your reference to it again, right? And then here we see that the parent is rendering the counter, and the child is also rendering the counter, and we're maintaining synchronicity, right? We both are rendering the same value, because the parent because it has a direct access, and then the child because we're passing a reference to it, right? Okay. And so this now opens up a bigger question, right? How is it? What are the best ways of maintaining states that uh, go across multiple components, right? And maybe even across multiple screens, or states that are relevant to an entire application, right? Wherever possible, we want to maintain, a very as narrow a context as possible in in state variables, right? So where we declare the state, presumably that's the only place where we are consuming, rendering, updating the state. But some state, is just, because of its nature, right? It's relevant across multiple screens, right? Maybe, who's currently logged in. If I log in, you know who is logged, the knowledge of who is logged in might be relevant across multiple screens, right? In the profile screen, when I'm looking at the products, I want to show the products, based on your preferences, right? So I need to know who you are. When I check out, I need to know, what's in your particular shopping cart, right? When I go into my uh, in my shipping screen, right, I need to know your address. In my payment screen, I need to know uh, your credit cards or whatever, your account information. So there might be multiple screens across the application that is everybody's interested in knowing your particular identity. So it might make no sense to maintain the state at any one particular component, right? Instead, we want to have we want to perhaps have that declared at a high level, right? And then share that state across the entire application. And that's where, we're going to have that discussion and have a, application-wide state, right? And where it might make sense to, decide that, hey, bits and pieces of the application state can be copied to a local state, use state, update it over there, and then click save, and then notify the top level state, right? And then that then gets fed to the rest of the application. So yeah, let's discuss that. Let's have a short break, and when we come back, we'll discuss state management, right? Application-wide state management. Okay. All right, I'll be right back. Don't go anywhere.